All right, let's get started talking about statistics. There are lots of different misconceptions about statistics, and part of my job would be to dispel all of those misconceptions. And in particular, in this first week, there is virtually nothing mathematical that's going to go on. There's some. Let me take that back. There's some. But the majority of what we do today is vocabulary. And there's a bunch. There's a bunch of words that you probably never heard of that need to get clearly defined. So an obvious first thing that would need to be said is, what is a statistic? Not what is statistics. Statistics is a science. It has a much more precise definition than that, but this is like a field of science. But a statistic is just a numerical summary. I'll say is usually a numerical summary. I have to have that caveat. Because we might collect a bunch of information about all the students at this school about what's the color of their car. Well, if your car is gray, that's not a number, right? But I could say something like 30% of students' cars are gray, and then I've got a numerical summary of what's happening at that school. A population The population can be anything that you want it to be. You can define the population however you'd like. You, as the statistician, you define it. So you might be doing some kind of research about, hey, are people satisfied at the hospital I work at with their job? Then you would have defined your population to be the people that work at that hospital. But if we want to talk about the salaries of nurses in the whole country, then your population is nurses in the whole country. So based on what you are studying dictates who your population is. It's usually big. There's usually your population is usually untenably large. Your population is usually so large that it would be inconceivable for you to do something like find what the average salary is, right? If we're talking about nurses in the whole nation and I want to know the average salary, it's going to be next to impossible for me to go to every one of them and collect the information on their salary so that I could do something like find the average. And it is exactly that problem of having the population be so big. Well, that's where statistics shines. Because statistics allows us to study what's happening with just a sample. The sample is just a subset of the population. It is a collection that's judiciously chosen from the population. It's a subcollection of the population. It is simultaneously sufficiently small so that I can compute things, but also sufficiently large so that I can extend the results I find in the sample to be some kind of fact about the whole population. For example, maybe I want to know what the average value of a home is in the DFW area. I want to know the average value of a home in the DFW area. So I should go to the ritziest neighborhood that I can find and just get like 10 housing prices. Does that sound smart? Of course not. I don't even know how many homes there are in DFW area, but depending on how confident I wanted to be that my findings were correct, I could compute how large my sample size should be. So there is some size of your sample that is manageably small, but matches the demographics of the whole population so that you can look just at the sample, find the average of that sample, and then use it to estimate what the average of the whole population would be. Okay? Here's a myth. We should not trust studies with small samples. Whatever small means. That's a myth. And it seems like it shouldn't be. The statement seems totally plausible, depending on what small means to you. But look at what they do with research for a new drug. They don't go and test that on every person. They test it on the smallest sample size that they can. One sample that demographically matches the population of people, or at least the population of recipients of that drug. And then use statistical tools to extrapolate from there to extend those results to a finding about the whole population. And it is that extension. That is what statistics is. It's how can I take a sample and reach some conclusion that is, in a way, irrefutable about the whole population. Something of sufficiently, something sufficiently strong that you could take it to court and it could be submitted as evidence. Something sufficiently strong that you would be willing to try this drug on people that were not part of the study. And you really don't know how they're going to react to it because it's never been tried on them before. But you know what the behavior was on your sample and you trust your sample to, you put your faith in the degree of confidence that is always conveyed with a statistical result. Everything that we do, or that you will do as a statistician, comes with like a condition. It's like, hey, this might be true, but we're only 90% confident that it's true. Okay? Or maybe we're 99% confident that it's true. And that degree of confidence is always stated. Okay? We'll do a lot more with that by the time we get to week 5. So we have a population, we have a sample. The sample is a sub-collection of the population. The samples should reflect the demographics of that population, and we'll talk about how we make sure that happens. But in order to conduct a study at all, we need a variable. Now, this is not a variable like x from algebra. It is a variable in the same sense that in algebra you had x, and you could just take whatever number pleases you, substitute it in for x, and get a result. A statistical variable is the same in the sense that I might say, I want to have the variable of nurses' salary. Then I could go to my sample of nurses, and each one of them has some salary. I collect that information from them, and it won't be the same for all of them. It will vary. Okay? So the variable is like the definition of the data that you're going to collect. A different example might be body temperature. I would say I declare my variable to be body temperature. And I go to my sample and ask everybody to give me their body temperature, or I measure it. And then I can make a list. I can form a collection of all of those body temperatures. And that would be what your data set is. Your data set is the collection of the values for that variable. So it would be weird if I was looking at my data set and it's got a bunch of body temperatures and then all of a sudden it's got people's weights, right? That's not, that I could separate them and form 2 different data sets, but the data set that I want to study would maybe only consist in the body temperatures. And I would have declared that variable first and then collected all of this data, formed it into a data set, and then I can do different things. Take its average, find the median, and so on. We'll talk about all those soon. Your variables have 2 distinct flavors. And at first, they're hard to tell apart. You may have, it's the wrong kind of discrete. It's not discrete like it's on the down low. It's discrete in this other sense numerically, or it can be continuous. Well, what in the world does that mean? Every variable that you could ever define is either discrete or continuous. And it can be tricky to, you might be given something and it is very tricky to tell them apart at first. However, if we reformulate what it means to be discrete or continuous with this other word, then I claim we can make it straightforward. Discrete should equal countable, and continuous, well, you might imagine, if I'm going to label this one as countable, and there's only the one other option of what it could be, what do you think I would call it? Uncountable. So discrete and continuous, those are statistic words. Countable and uncountable, those are math words. And they mean the same thing. A discrete variable is a variable which is countable. Continuous variables, you cannot count all the possible different values that could go into that variable. Now, let me give you some examples of collections that are countable. The collection 1, 2, 3. By the way, when I use these things, they're called curly braces. That's the official name, curly brace. And they house a set. So if you have curly braces, the things between them are the elements of your set. Can you count these? Obviously. Then whatever variable this might represent, maybe it's number of siblings, then number of siblings, countable. I can count up, or that's a bad example. Anyways, it doesn't matter. I've got these three things. You can obviously count them, even if it said A, B, C. It's countable. Is the alphabet countable? Obviously. Based on those examples, like these two things, the alphabet, couldn't we say that collections that are finite are countable, no matter how large? Yes, we could. If your collection is finite, it is countable. It's easy to see that because even if it was all the people at West Coast University, I could go through and I could label each one of them. 1, 2, 3. Eventually, I'll get to the very last one, but still have a bunch of numbers left to go that I could assign to someone. So that makes those collections finite. If it's finite, it must be countable, in which case it would be discrete. What about the collection that just keeps on going forever and never stops? Is it countable? So here's where it'll start to get tricky. To be countable, by definition, means I can assign a unique integer to each of the objects. And for this collection here, let me make the assignment that just each one of them shall be assigned the integer that they are. So this one is assigned 1, and this one is assigned 2, and so on. And I never run out of the integers. This collection is countable, even though it's infinite. This is countable. Suppose my variable is the number of stars in the observable universe. Is that countable? Indeed. I don't even know that it's finite, and don't need to know, because so long as there's a little bit of space between each one of them, then I can go through and label them with a number. What about all of the grains of sand on the whole earth? Is finite. It's up here. It's not even infinite. The number of water molecules in an ounce of water is finite. It's going to be awfully hard to label them, but it's most definitely finite. And if the question was the number of water molecules, it would be countable. But they're not going to ask you that. They're going to ask you about the volume of water in a beaker or something. Then you run into a problem, because we would need to go, so our variable would be volume of water in a beaker, and we would need to go through and see if we can count all of the possible volumes that could ever be in that beaker. And depending who you ask, it might be countable or uncountable. If you ask the people who wrote this, it's uncountable. And I'll show you why. But if you think about it from a chemist's perspective, it would be countable, because at the minimum they could do would be to add one more molecule at a time. Though that may be impossible to do, you could generate a countable list of all the possible volumes. So what we will have to do is, as we complete the homework, I will have to guide you on what is a proper restatement of the question so that it can be answered correctly. When it comes to uncountability, let me ask you this. What I'm writing here is a numerical interval, right? I can make a sketch of it on the number line. So this collection right here corresponds to all of the numbers on the number line between 0 and 1. It's all of these numbers in here. Is it countable or is it uncountable? Uncountable?
Between 0 and 1?
Yeah.
Uncountable.
How do you know?
Because you're going to have fractions. And you said that the countable ones are the integers, the whole numbers.
It's true. However, I could make a grid of all the possible fractions that you could ever have. 0 over 1, 0 over 2, 0 over 3, 1 over 1, 1 over 2, 1 over 3. And they just keep going this way. They keep going this way. I could have negative 1 over 1 over here with over here would be negative 2 over 1. It keeps going this way. Up here I'd have negative 1 over 2, negative 1 over 3. Screwing bring this up, hold on. I want on each row I want the different denominators. So let me start over. So I'll have denominators here like 2 and then 1 and then 2 again and then 3. And the numerators would start off at 0 and count up. So then this would be 1 over 2, and 3 over 2, and 4 over 2, on forever. And this is 1 over 1, 2 over 1, and 3 over 1 forever. And these were supposed to be my negative ones. And down here I'm having my positive ones. And I could continue in this way and make every possible fraction that could be made. I keep going down. As I go down the grid, the denominator changes. As I go across the grid, the numerator changes. Would you agree that I could make a grid that showed all of the different fractions? There would be some repeats.
Yeah.
But if I'm changing the denominators as I go down and changing the numerators as I go across, and then I've got 0 here, I got the negative ones, positive ones down here, then you can count these. It's countable. This is a countable collection.
Yes.
You can start here at 0, and the next one that you go is right here, and then here, and then here, and you just keep going around in this spiral forever until you have counted them all. It's this spiral argument. So this is a countable collection. In other words, the collection of all the fractions is countable.
Yes.
It's not even uncountable yet. So then we're back to this interval between 0 and 1. You said it's uncountable. That is correct, but the reason is not because of the fractions. Although it would seem that there are way more fractions than there are integers, but there's the same quantity. And that's a peculiarity of infinity. This collection is uncountable, and it's actually surprisingly easy to show why. Let us suppose that I could make a list of all of the numbers between 0 and 1. And this listing can be in any order. It's just like a random ordering of all the numbers in between 0 and 1. And so such numbers might look like 0.1, 2, 3, 4, 5. Who knows? It just keeps going. And then the next one, and I'll call that one number 1, right? And then the second one, this one actually has like a bunch of zeros, and then it's ones forever. And then the third one on my list is actually just 0.1 and a bunch of zeros forever. And this list I've made is random, but my claim is that I have every one of them on the list. Let's put one more. What should it be? How about it's just all 7s? I don't know. If it was all 7s, that's actually the fraction 7/9. So, and this one here is 0.1 with nothing but zeros after forever is just 1/10. So this list would have not only the fractions, but it would also have numbers like pi, whatever that, 3.14159, and so on. And it would have any conceivable decimal number you imagine. My claim is that it's on this list. Okay. If my claim is true, then this would be countable, right?
Yeah.
If my claim is true, then this would be countable because I have produced the list that had all of them, and each one of them was assigned an integer, even though it was an infinitely long list. Well, here's how you can know for certain that my claim is wrong. We can construct a decimal number that would not appear anywhere on this infinite list. You would be guaranteed that it could not appear. It goes like this. So here we go. Let's make the number. It'll start off as 0 point something because it's between 0 and 1. The first digit here, to obtain that digit, I will look at row 1 and see that the first digit there is a 1. So I'll just make this one a 2, just one more. So I would have used that number to determine what this one should be. It's just one more back. So then already, no matter what this first number was, this number it cannot be that one because they disagree right there at the first position. And this one, the second one on the list, has a 0 there, so this one will be a 1. So it can't be the first one on the list, and it can't be the second one on the list. And I can just continue like this forever. This one's a 9, so I'll just roll it back over to 0. And then this one's a 7, so this is an 8. And it just goes on. You put another number here, and I'll show you how I make this one not equal to that one guaranteed. Then this number that we've constructed cannot possibly be on this list. It has no integer assigned to it because it can't be the first one, and it can't be the second one, and it can't be any of them because of the manner it was constructed. And this number not being on this list, even though this list has fully exhausted all of the integers all the way to infinity, because there's a whole bunch of them, we have a number here that doesn't have an integer assigned to it. So we would run out of integers trying to count all of the numbers between 0 and 1. That's what makes this little interval be uncountable. So then when you see a variable, like let's say the distance from me to that window, there's a bunch of different distances from me to that window. The question would be, can I count them all? Well, similar to how we have this number line, a continuous object. There is this continuum of distances from me to that window in such a way that it is not possible to count all those distances in the same way that if I have, maybe the question is, the volume of a pool, the volume of any pool. Well, then we can construct a pool of any dimensions we would like, thereby having this collection of volumes that is uncountably large. An uncountable collection is necessarily infinite. But we saw that there are some infinite collections that are countable. So if it's finite, though, it's definitely countable. If it's infinite, there's a gray area. It might be countable, it might be uncountable. But if it's if it's uncountable, it definitely is infinite. It's time for our break. When we come back, we will look at the corresponding questions to discrete and continuous, countable and uncountable from the homework. And you will see that more than half the time, the question is inappropriately written, and it has to be thought of carefully. I will have to convey to you a different thinking of the question in order to get it answered correctly, right? And I'll show you what all the possible pitfalls are. And discrete and continuous, that's like the hardest stuff of the day. So if you're getting that, it'll be downhill from here. All right, 10 minutes.
And that last thing that you said it's infinite, it's uncountable. Did you say that before you cancel?
If it's uncountable, then it's infinite. You see the difference?
Yes.
Being infinite, not necessarily uncountable.
Oh, I see what
But
you're
if
saying.
it's uncountable, then it is absolutely going to
I
be
see what
infinite.
you're saying. And not necessarily a little.
Exactly. Exactly.
Has anybody been here more than 2 terms?
Yes.
Is it normal for classes to be this small?
It can be. There are some classes that are small, my night classes are big.
Really? Yeah, because I was kind of shocked when I first came in here. There was like, what? There's 3 else in here.
You're missing one person, I'm not in this class.
Oh.
You're missing a person, so it will look like this.
Okay, so it really is just
Just
us.
depends.
Okay. It's so weird. Do y'all feel like y'all getting it? I feel like that way too, but it's like, I'm really, really bad at math, and so I've been really nervous about this as soon as I realized I was taking statistics this term. So I'm like cautiously optimistic at the moment.
I'm trying not to think negative. Everyone has said, I told that I'm taking statistics, like, yeah, good luck.
Literally, I've always heard that forever.
Yeah, I'm like, I don't want your negative juju. Like,
I think that's another reason why I'm like so scared. No, like seriously, like this, going back to like middle school, I remember always having to have like additional help with math, and I don't know why. You know, like in high school, I failed a semester of chemistry because I remember having to go to summer school because I didn't understand the math to it. You know, physics, same thing. I failed a semester, I had to take it over in summer school. I'm just really bad. Really bad.
my whole family hates me.
Yeah. See, I don't. My mom is an accountant. Like my other brother, he's studying to be a doctor now. But before, like whenever he was in high school, he's like, I think I want to be a college professor. He's like, as long as I just get to do math every day, I think I'll be happy. Like that's numbers are not my thing.
That just missed you, huh?
Yeah, just jumped right over me.
We got this though.
Yeah, I think it's gonna really help to be able to go do the homework, you know, together, because I feel like we'll all understand, you know.
And have questions and stuff.
Okay, so do we take the quiz like here, or do we take it like at
So no, yeah, it sounds like the quiz is more like homework. So that's what I'm saying. That, so the homework we do together collectively, and then the quizzes and the midterms we do on our own. On our own time.
Okay, because I was confused, like, we do the homework and then just learn it and we have to take the quiz.
Yeah.
Yeah.
That's what I was confused with.
Yeah.
When do y'all start for?
Next year.
This fall,
This fall.
I'm a transfer student, so,
Oh, where's the transfer from?
Common College, community college, and.
Yeah. My mother tried before I came here. She like was really like pushing for me to go over there. Why did you transfer out? If you want to ask.
They don't have a 4-year, so for there you have to do the associates before you can do your bachelor's. So here I can get my bachelor's in the time that I would still be doing my associates for there.
I see. Okay. What other classes are they taking this term? What other class are they taking this term?
Just anatomy.
Anatomy, me too, with Star, Instructor Star.
Mhm.
How are you feeling about that?
Hopeful.
As soon as the, yeah, so I'm having to retake it, so, I took a long break from the studies, and so I'm back, and so some of my credits, it's just been way too long, so I'm gonna retake some stuff.
Mhm.
So I did well with anatomy this time around, so I'm not too nervous. But like as soon as her announcements came through yesterday, I was like, oh.
And I'm like, hey, slow down.
Right? I was like, we are in it.
I'm like, this should be a part of like, you know, the modules, not the announcement. Like
Yeah.
the announcement was intense.
Yes, it was. And it was announcement after announcement. I'm like,
Yeah.
They don't let us edit the modules.
really? Oh,
Yeah,
really?
that's why it's in an announcement like that.
Oh, okay.
That
Um,
was dense.
she's amazing.
Yeah. Okay.
Oh yeah.
She comes out as like really like I don't know, like in her introduction, or I'm looking forward to meeting her.
She's the most friendly person
Yeah.
I've ever met.
Okay, she definitely comes across that way.
Yeah.
Yeah.
And you will definitely enjoy her class.
What are you saying? Oh, I'm sorry.
No, you're fine. FHE.
FHE with Dr. Walter.
Yeah.
He's
You had him?
super cool.
He's so
I had him.
animated. I
Yes,
love
he's
him.
funny. And I love the way he structures everything. Like, there's literally no room for questions. Like, he's very, very
Yeah.
informative. I like that class.
Mhm.
Yeah, I didn't even ask you y'all's names. I'm Vanessa.
I'm Crystal.
Crystal.
Estefania.
Estefania.
Mhm.
Nice to meet you.
I'm Allison.
Allison.
I'm Carissa.
Okay, so you're the other person that did the introduction. I read your yes. Okay.
So let me point out that while it's possible to go and look at what the future discussion boards are, they won't all stay with the same discussion prompt. Some of them I will update the discussion prompt. So be careful in deciding that you want to get too far ahead. You know what I'm saying? All right. Let's look at one more question. So the first thing that they're wanting to talk about is discrete and continuous. And so you should open up your assignment, and conceivably the question you are asked is along the same lines, right? But if we need to work on yours in particular, then you just ask me. The numbers of teeth that different animals have.
I feel like the wording is weird.
So we've got a bunch of different animals. Maybe we can start off to say the numbers of teeth of any possible animal. Well, I know what's the deal with my teeth, at least. I can count them. It's a finite collection, right? If I were to look at a giraffe, could I count their teeth? Pretty much, no matter what animal you were looking at, you can expect to be able to count their teeth. Even if they had an infinite number of teeth, we could count them. So this is discrete. This is discrete, and we'd have to be careful here. There's two options for discrete, but this second one is nonsense. Because if the data can take on any value in an interval, that's literally what we meant by uncountable, right? Because in the interval from 0 to 1, you had an uncountable collection, then we can say that for any such interval, no matter its size, it houses an uncountable collection. So be careful that you're choosing the correct discrete option. There's only specific values. You can have 10 teeth, or 24 teeth, or 1,000,000 teeth. But I'll always imagine the job of the dentist on a patient that had an uncountable number of teeth. Not only would they never finish, they wouldn't know where to start. All right, so what do y'all think about your question 1? Any trouble figuring out the answer? Everybody got it? No?
No. Okay, so mine's like number of words in books.
Number of words in books. It's excellent. Something to think about. Okay. So, think about, choose any book at random. Can we count all the words in that book? Yes. Think about the book that is constructed, the fictitious book that is constructed by taking every book that has ever been published and then just stacking them front to back, making the biggest book that had ever been. Could I count all the words? Yes. Even if I modified it to say the number of words in every book that has ever existed or will ever exist. If time just keeps on going forever, which it actually doesn't, if time just kept on going, then you could conceivably have a book that had an infinite number of words, but you could still count them. 1, 2, 3, 4. That's discrete.
So,
If it was, let me put it like this. If you had a book with an uncountable number of words, it would not have a first word. In the same way that the interval from 0 to 1 does not have a least number. You might think the lowest number is 0.000001, but all I got to do to make a number lower than that is stick another 0 in here, and I can do that forever and keep making another number lower than the one before it. So a book with an uncountable number of words wouldn't even have a beginning. Yeah, that's out of the question. So there, the discreteness would come from it being a book, what we define a book to be. You know, books have properties like having a beginning and an end, a first and a last word. Any other questions?
Will you explain the difference, like, so for that one it's like discrete because it takes on specific values, but then the other one's just discrete because it
Take on any value in an interval.
will you
Yeah.
explain the difference in that?
So when we have our interval of values, that's like that interval from 0 to 1. If it could take on any value in an interval, that is the definition of continuous. Something is continuous whenever there are so many different possibilities for what that number could be, that it could be any number in this interval. Yeah. Imagine a child that's growing, and you know how they mark on the wall the different heights, right? That child didn't suddenly become the new height. They had to continuously, smoothly change through all the possible heights to this new height. That's continuous. So in other words, if you decide that it's discrete, then it must be the one that takes on specific values, because this one, for any value in an interval, that's what goes with continuous.
Okay.
Yeah.
My question was, the heights in feet of different buildings.
Yes. Okay, that's a question that's worded not so great,
Okay.
because they said in feet.
Okay.
And I know what they meant to say. I know what they're getting at. The key words there is that it's a height. As soon as we stipulate that it's a height in feet, our options are truly limited. Because if I was only talking about the height of a building, then it might be 100 feet plus 0.002 feet. You know, so we would have to assume that the author meant not a round number of feet, but that it can be some portion of a foot as well. It would be analogous to the distance from me to the window. You know, I'm 13 and a half feet away right now, but if I move one iota this way, then I'm 13.6 feet. But everywhere in between when I moved, as I move this way, I'm covering all of the different possible distances from me to the window, and there would be no way to assign a number to each one of those possibilities, because I'm moving in a smooth manner in the same way that the number line transitions smooth. If I drag a cursor across the number line from 0 to 1, it will go through all those different possible numbers for which there's an uncountable amount. Right? Anything really that's transitioning smoothly, that could have a smooth transition. If I look at this building here, well, maybe that wouldn't really apply to a building. If I look at the height of any building in the world that exists right now, well, there's only a finite number of buildings in the world. So technically, the answer is discrete, but that would be counted wrong, because the author of the question intends for you to understand that things like lengths are continuous, traditionally continuous, because instead of looking at all of the buildings that do exist, we would look at all of the buildings that exist, that could ever exist, that have ever existed, and even the buildings for which we could make but don't exist and never will. Then suddenly the collection of buildings becomes much larger. I could make the Empire State Building, but then I could make the Empire State Building with one extra atom on the top of it, you know, and that's a new height. It'd be a different building with a new height. So things like lengths are continuous.
So in that case, it could take on any interval?
Any value in an interval. Mm-hmm. You good?
I think I understand it, but I don't.
I know, it's tricky. Let's look at some more. So they just have questions 1 and 2 about it. Let me get some. I have an answer question 2. Oh, it gave me a different one. The number of homework assignments that different students turn in for a class. Discrete. Because it's finite, right? Else we'd never finish the course. You'd be turning in assignments forever.
Well, can I go back to that question about the length?
Yeah.
So we should assume always that time and length, things of that nature, should be accountable because they're continuous, even if we're given buildings that have intervals that are a certain set number without any fractions or decimals. Just always assume that length, time. Okay.
Yep. Because when they write the question, they're not considering those what they're actually saying, yeah.
Okay.
When they, I write these people's letters all the time. If I encounter a question that's just egregiously wrong, I'll message them. And I've had a lot of them changed or just outright deleted. They had one time that was the number of red barns in a state or something like that. And I made them remove the question because they kept saying, well, no, that's maybe it was the number of red barns in the whole world or something like that. And they wanted to claim it was continuous.
Because it continues being built.
Well, because I couldn't even argue for why they would think that. I mean, even if every building on the planet was a red barn, and every square inch of the surface of the earth was covered with red barns, I could count them all.
Yeah.
And so it's discrete. And they removed the question. So that they concede that and this is a new, this is a revised version. This just came out last year. They revised everything and reissued it. So it'll never be absolutely correct. Because if they did write the question in an absolutely correct manner, they would discover that everything is discrete. That there really is nothing continuous. Let me put it like this. You have never seen an infinite collection in your life, with the exception of me writing out like the integers. When you look out at the stars, we don't even know if the universe is infinite. We can only see so far.
Yeah.
There's a finite number of atoms that this earth is built from. It's not only not infinite, it's finite. Everything that we see is finite in nature from our perspective. And that's like missing what their point is, right? They're trying to test your knowledge about the difference between discrete and continuous in this way that's a little bit inappropriate by asking these questions that are poorly worded. The number of homework assignments. Well, this can be used to make sure you understand what it meant to be discrete. But when they want to have a question whose answer should be continuous, that's where the problem is usually at.
Question.
Yeah.
I don't know if I'm just overthinking it. So mine is the exact depths of the ocean at different points around the world. So I want to say that that's continuous because we don't know how deep the ocean is. But am I overthinking it? Is that where my thought process should be going?
You have to suppose first that we could measure all those depths, right?
Okay.
Okay. Then if we laid out a grid across the whole ocean, a grid of whatever size you would like, and then go measure the distance of the ocean at that point, then we'd form a finite collection. But when they say you can go to any point and measure the depth, that's continuous. Because I'm no longer constrained to having formed a finite or even an infinite collection, because as soon as I measure the depth at this point, I can scoot over by an infinitesimally small amount and measure it again.
Okay.
And I can spend an eternity measuring the depths in a region of the ocean that's this big around and never even get out of it. But what they really wanted you to, let's boil the question down to what it really is. The question should read, is length discrete or continuous? Because depth is a length.
Right.
Yeah.
Okay.
And that would be the trick in understanding how to just get the right answer, right? Even though the story is a little deeper.
What about weight? Would weight be continuous as well?
In so far as you would like to answer the question correctly, yes. Right up until the point where they say the weight of West Coast University students. Well, there's a finite number of West Coast University students. So I would only form a finite collection of weights. However, those weights could take on an uncountably variety of different values. You might be 130 pounds, or 130.1, or 130.001, or 130.0001. And I can just do that forever and never even leave the weights associated with 130. Continuous. So that's the first two questions. Has everybody got the first two questions done? All right. So when you get to the quiz, you're going to use the trick of lengths, times, weights, continuous. Everything else is going to be discrete, and you can verify that because you could count it, like the number of teeth or the number of words in books. Variables have different levels of measurement. And there's this hierarchy to the different levels of measurement. So I'll start at the bottom, and then we'll graduate up to the highest ranking. It's not that one is preferred over the other. It's just a matter of the appropriateness of what you're trying to measure. So at the bottom is the nominal level of measurement. It is the lowest ranking of the 4 levels of measurement. There's 4 of them. And it is demoted all the way down here to the bottom because something at the nominal level of measurement is nothing more than a name. It's a replacement of a name. It's a name. For example, your student ID number is at the nominal level of measurement. It's a direct replacement for your name. Your driver's license number is at the nominal level of measurement. It's a replacement for your name. The color of your car. All of those things are at the nominal level of measurement. We would say that something that is at the nominal level of measurement has no well-known ordering. So you will likely encounter a question on the assignments that discusses jersey numbers of some team. Well, that jersey number is just a direct replacement for the name of the player. And there's not a well-known ordering to the jersey numbers because while sometimes, like the quarterback has the number 1 for their jersey or some other low number, it's not required. Just because you had jersey 1 didn't mean you were the first one on the team that ever joined. It doesn't mean that you're the best one on the team. It doesn't mean anything. There's no well-known ordering. It's just nothing more than your favorite number. So things at the nominal level of measurement, there's no well-known ordering. Well, then that tells us what the next highest ranking level of measurement would be, and that's ordinal. Things at the ordinal level of measurement do have a well-known ordering. If you were competing at the Olympics and won the race, but they handed you a silver medal, you'd be upset. Because you already know the ordering to the variables, gold, silver, bronze. They go in that order. Gold is number 1, silver is number 2, and bronze is number 3. And if you came in first in the race, then that should correspond to you getting the medal associated with number 1. Tell me a collection that is ordinal, but not numerical, different from the gold, silver, bronze example. It's way too easy to have a numerical one, right?
Grading system?
Yes. A, B, C, D, and so on. That's a great one. Is there another? You would have learned it when you were 2, 3, 4 years old. Alphabet.
Yes.
There's a well-known order. If I start saying the alphabet all out of order, you'd go call the dean. This guy's sick. He needs to go. So the order of the alphabet, well known. The gray area here, insofar as what's on the assignments, is colors. I've seen a question before where it's like the colors in a box of crayons. But I've seen OCD people arrange those in the order of the rainbow. The rainbow is the color comes from frequency of the wavelength, or frequency of the light wave. So if the light has a low frequency, it's more red, and if it's got a high frequency, it's more violet. That's why you have infrared, ultraviolet. And that change in the frequency is a natural, well-known ordering, but they want you to answer it as if you didn't know that. So if you encounter a question where it's like, colors of the box, dump out the box of crayons and put them into the well-known ordering of color. Well, you can't decide that green is less than orange. That's not truly well known, even though you could painstakingly sit there and put them in that color of the rainbow. To graduate above ordinal. So we're down here at nominal. It's just a name. There's no well-known order. It's definitely not numerical in the sense that we can add 2 driver's license numbers together and get something meaningful. It won't be someone else's driver's license. It's not likely to be someone else's driver's license number. And even though you could take driver's license numbers and put them into a numerical order, you could sort them into numerical order, that ordering won't tell you anything. All it would tell you is who has the first driver's license number, who has the second lowest driver's license number, and so on. And it's usually the governor of the state that has the lowest driver's license number. They saved it for them. When George Bush was governor of the state of Texas, I think his driver's license number was 2 or 7 or something like that. It was like 0000007. And they gave it to him after he became in charge. So, but if I were to order the driver's license numbers that way, I wouldn't be able to learn anything good, right? It wouldn't tell me who's the best driver. So that ordering is useless. To graduate above ordinal, we have to consider these next 2 kind of simultaneously. They are interval and ratio. Now you can think of them as, if I just look at the perspective from ordering, we have no well-known ordering. And then here we do have a well-known ordering, right? So both of these should have well-known orderings, but just some more stuff added to it. Down here at ordinal, I couldn't take the differences between two things and have it be meaningful. I can't take if I take in the alphabet B minus Q, it is not a new letter of the alphabet. B minus Q. It's meaningless. So interval and ratio have the property that differences are meaningful. Differences are meaningful. Both of them have this concept. Differences are meaningful. So, if I was waiting in line for at the drive-thru for a coffee, and the person in front of me waited for 3 minutes, but I had to wait for 5 minutes, the difference is 2 minutes, and that number 2 describes the difference in our wait times. And something like that would be at the ratio level of measurement. Whereas if I had a list of college rankings from 1 to whatever, and if I took the 3rd rated college and subtracted it away from the 6th rated college, that difference is 3. But the result is not a college that is 3rd, whose ranking is 3. Although I may find out the difference in their rankings, taking that difference is not also a college ranking. Different, and that's different from up here when I was talking about waiting in line. Because when I took the 6 minutes minus the 3 minutes, I got something that also had the units of minutes. And it was a time, right? So a concept like the time that you are waiting is at the ratio level of measurement. Interval is the very hardest one to have examples of. The canonical example of something at the interval level of measurement is temperature. Temperature. Because if it was 90 degrees today and 50 degrees last week, then 90 minus 50 is meaningful to me because it describes how much warmer it is this week than last week. That number is also a temperature. But if I had movie rankings, Hollywood blockbusters, and I took the number 1 ranked movie minus the number 4 ranked movie, or do it the other way around. Take the number 4 ranked movie minus the number 1 ranked movie, the result that you get is not a new movie whose ranking is 3. Something like that, movie rankings could not leave ordinal. It has a well-known order, that's it. Because when I start taking the differences in those rankings, it isn't producing for me movies with that corresponding ranking. When I start taking differences in wait time, it is producing for me new quantities of time that can describe that can itself be a new wait time. I had to wait 5 minutes, they waited 3 minutes, the difference is 2, So really, I had to wait 3 minutes, and then I had to wait 2 minutes. So that difference was a wait time. If I look at the differences in two temperatures from this week to last week, that difference is also a temperature. But when I look at movie rankings, the difference between those two is not does not describe the ranking of this other movie. Right? So far, we don't have anything distinguishing interval and ratio, but look at these examples and tell me what might be something that could distinguish the two. It would probably be more obvious if we all lived up north.
You're asking what's the difference in those two, right?
Yeah.
So with the ratio, it's more of a comparison, and the interval are changing over time?
Well, based on these two examples, you can discern what the difference must be if you can identify intrinsically what is different about temperature than how long I waited for something. Think only of just Fahrenheit for now, or Celsius if you'd like. How cold is it in Siberia? What's the temperature in Siberia? What's the temperature at the North Pole?
Freezing.
Freezing. Is that it? Freezing is 32. Below freezing. So 0 degrees Celsius is where water freezes, and it's below that. So it can go below 0. Can I have a negative wait time though? No. That's the only difference. It's at the ratio level of measurement if it starts at 0. It's at the interval level of measurement if it does not start at 0. So it's at the interval if 0 is not a starting point. Well, you may say, oh, well, hold on now, Mark, because you gave it away. What if I were to talk about the Kelvin temperature scale? Do we know what that is? It's just defined in terms of Celsius. Right? And there's this concept there of absolute 0. It's negative 273.15 degrees Celsius. And it is at that temperature where there is no more energy at all. Whatever vibrations were occurring in the molecules has stopped altogether. But that's not a temperature that is possible to achieve. Electrons have an intrinsic momentum. They will always have an energy level above nothing. You would never be able to cool a substance all the way down to 0 degrees Kelvin. You can only continue to get colder and colder and colder. You can asymptotically approach that temperature at the bottom of the Kelvin scale, but you'll never get there. You'll only be able to get colder and colder. In the same way that we could have 130 pounds or 130.1 or 0.01 or 0.001, and I can just keep sticking a 0 in there. You can just keep getting colder and colder, but you would never reach 0 degrees Kelvin. It's impossible. The only way that could happen is, the universe is expanding. It would have to expand for eternity. Protons would have to decay, and since everything is moving apart from each other, everything would have to move out. Your observable universe would contain one electron. That would be the minimum such case. And even then, that electron cannot reach absolute zero. Well, you may say, well, way over there where there isn't an electron, maybe it's colder over there. And that would be the only thing that I could think of that could make that happen. Is that over there, if you could measure the temperature somehow or another with your device that doesn't actually exist because it's made of molecules, then, like in other words, to reach absolute zero, we have to be at the end of time. The universe has to expand maximally. Everything is as far apart from each other as it could possibly be, and everything has cooled off to the same temperature. But even if that happens, I claim it's still going to be very challenging to reach zero. So we might as well assume then that even if I had Kelvin as my temperature scale, you still cannot have zero as a start point. Then temperature is nearly the only example I can think of for interval. You would have to have something that whose differences are meaningful, that does not start at zero. Maybe we'll see one on the assignment. Let's have a look at it. This was already one of our examples. How about that, huh? Letter grades in a math course. They're at least nominal. Are they better than nominal?
I guess they get order up.
They go up to ordinal because if you got every question right and I gave you a C, we'd have a problem. So they do go in order, but they can't be past ordinal. They can't be past ordinal because they can't be interval or ratio, because it doesn't make any sense to have a negative letter grade, right? And letter grades don't start at zero. Differences of letter grades are not meaningful. If you made an A and you made a B and I took A minus B, then there wouldn't be a new student over here who would get a grade of A minus B. That just doesn't make sense. You know what I'm saying?
Yes.
So this would be ordinal.
Can I ask a question?
Yes.
To the example that you gave about rankings of bigger movies,
Yes.
how would that be labeled under the level of measurements?
Start at nominal. They're at least nominal, right? All of those rankings could be substituted as a name. Okay, can we do better than nominal? Well, it's a ranking, so we're at least ordinal. Can I go above ordinal to interval or ratio? You can check that by saying, if I took two movies whose rankings were this and that, subtract this and that from each other, and ask yourself, do I now have a new movie whose ranking is this quantity? No.
That's why you said that.
Yeah.
Okay.
Volumes of brains in cubic centimeters. To answer the question properly, we would have to assume that a valid volume of a brain is to not have one at all. Right? Your cranial capacity is 0. Which is, of course, impossible, but is a volume. Maybe if we got a zombie attack or whatever and my brain got eaten, I wouldn't have one and my brain volume would be 0. So what do you think? Ratio. It is ratio. Justify your reason.
You said it can start at 0.
Start at 0.
That's it. That's my.
Okay, that's good enough. If I took the differences between two brain volumes, does that number carry any meaning to you? Are the differences meaningful?
Yeah.
Yes. So ratio level of measurement is most appropriate because look at how it contains the previous ones. It can be ordered. right? And if I were to take two different brain volumes and take their difference, it would describe to me a new brain volume that I can like do something with. I can say, well, this brain has this much more volume than that one. It is ratio.
That's a question.
Please.
Back to favorite movies.
Yes.
We said that was most likely order.
Yes.
For favorite musicians, how is that different?
Okay.
The answer is not saying.
Let's see. So, favorite musicians. Is it your favorite musicians?
It just says favorite.
Just says favorite musicians. Is the ordering well known? If you made a list of your favorite musicians and we compared it to her list of favorite musicians, are they the same?
Most likely not.
No. If I conducted a study and just took a poll of everybody in the country of what their favorite musician would be and then made a listing, it would be different from what would happen in India or China. Yes?
So mine's favorite colors. I thought it would be ordinal, but it's not. So it's not ordered.
So there's two things that would disqualify that as nominal. They could just get rid of the favorite part and just say colors. Nominal. Even if it's, but if we consider your favorite colors, favorite colors, then your favorite colors might be different from the other person's favorite colors. Yeah. So the ordering is unique to you. It's not well known by everyone. Someone that I couldn't drag someone in out here and say, hey, what's her favorite colors? And then have them know. You know what I mean?
Right. Okay.
This question is particularly deceptive. To properly word the question, they should actually delete all of these examples that they're trying to give. This is not helpful. It is these examples that's causing the problem. If they had just said voltage measurements of batteries, and then I will ask you, has your car ever not started because the battery was dead? So it starts from 0. It goes up from, no, not interval. I can't have a negative voltage on it. Technically you can.
I'm sorry.
But we're not to consider that here.
Ratio.
Ratio.
Yeah, I read it wrong.
Yeah, no problem. Ratio is the appropriate level of measurement from here. If I were to only look at this, I might think that I'm not supposed to deal with ratio. They didn't put 0 as one of the possible voltages. I might be thinking that I only have these 5 batteries and that these are their voltages and I'm supposed to decide what to do with it. In which case the best that I could do would be to order them because it didn't start at 0. And let's see if I'm right.
So is there a situation where the differences will result in a new something? Is that something that we should be looking for?
If I took 2 batteries, and so the word differences is even that is misleading. It could be any addition or subtraction, right? Let's take 2 batteries and hook them up in series. I got a 9-volt and another 9-volt battery. I hook them up negative. I took the negative terminal of one, I hooked it up to the positive terminal of the other, and I check the new voltage of my new battery that's formed from these 2 batteries, and it would be the sum of the voltages of each.
Okay.
Yeah. Anything else? Okay. That's all the questions that they're going to ask on levels of measurement. Ready for the next section? after levels of measurement, they want to talk about the way you're collecting the data for your variable. Sampling techniques. There are 5 different sampling techniques. And I'm going to present them to you in the order that you should inspect. You'll look at your problem and you'll say, I would like to know what the sampling technique is that they used here. And then you will come to this flow chart or whatever you want to call it that I'm going to present, and you'll go, it's not this one, and so I would go on to the next one, and then is it one of these? No, and then I must be in the last case. Okay. So the easiest one at all to recognize is called systematic. The systematic sampling technique would be commonly used in a place like a factory. Okay, I go to the factory and they make sutures, and I'm going to inspect for sterility, and so I go over to their conveyor belt, and the sutures are just whizzing by. My system to select the sample, because they have far too many for me to check the sterility of every one of them. My system will be that I will, the conveyor belt's empty, and then here comes the first one, right? It's about to go past me. So I will wait until, let's say, the 135th one goes by, and then, or I'll wait till the 134th one goes by, and then the 135th one will be the first one in my sample. I just picked 135 at random. You could have picked any number. Right? I'm just giving you an example. The next one that I would select would be the 135th one plus, and here's where I pick another random number, like 10, let's say. So the next one would have position 135 plus 10. So it would be the 145th one on the conveyor belt. And then the next one after that would be the 135th one plus 10 plus 10. Just keep adding 10 over and over and over. Now, there's a concise way to make these statements because this one here would be 135 plus 2 times 10. The one before it would have been 135 plus 1 times 10, and the one before that would have been 135 plus 0 times 10. And you can just keep on going with this list, and then the only thing that would change is that number. And it would keep incrementing by 1. It starts at 0, and it keeps incrementing by 1 until you get down here to the bottom. Let's say I wanted a sample of size 10. I wanted 10 sutures in my sample. Then what would be the last number in this list right here? 0, 1, 2, and the last one is? That would be a size 11 sample because it starts at 0, right? 1, 2, and so on down to 10. From 1 to 10, there's 10 numbers, but by the time you throw in 0, there's 1 more. So to have a sample of size 10, I'd have to stop at 9, one before it. Well, if this is my strategy for calculating, when I write it like this, it's easy for you to see which one on the conveyor belt is the last one from my sample. It's number 135 plus 90, so it's number 225 on the belt. Then a systematic sample, you start at some random number. It's up to you. It could be 0 if you want it, or it could be 46. You just pick something. And then you add to it some integer times this other random number. There's 2 random numbers involved. There's the place you're going to start at and how far over you're going to go to get to the next one. and you just let n count, that's a systematic sample. Make sense?
How would you put it in terms for note taking?
I want to put it in terms for note taking. A systematic sample is where each member of our sample is selected by the formula right here, this formula, where these two numbers were randomly chosen and n varies from 0 up to some number, call it k, where your sample size would become k plus 1. I ran out of space, but I would have said many. How many? K plus 1 many, whatever the number that is. So this is a concrete example, and this is the general example. Now, by the time we get to the end of the course, you will have to conduct a systematic sample from this big list. I've got a big list of heights and shoe sizes. They're numbered 1 to 500. You would collect a sample of size 9 from that list, which would involve you picking a place to start and deciding how far over you're going to go to get to the next one. And since the sample is size 9, you would have this number here range between 0 and 8. So if you were going to start at the 10th one, and you were going to skip every 30, let's say you picked 10 and 30 for your random numbers. Then this would be the formula that you're using, 10 plus n times 30. And you would consider all of the values for n to be from 0 to 8 because you wanted a sample of size 9. You can tell me then, well, obviously we're going to start at the 10th one on the list. You could tell me the number on the list of all of the people in your sample. For example, the last one would be 8 times 30 plus 10. That's number 250. The sixth one on your list would be 6 times 30. Well, that's 180 plus 10. That's number 190. Get it? So, but this is extremely formal. When you look at the question on the homework, it's going to be like a company wants to survey their customers, and they get out the list of their customers and call every 30th one. Is it systematic? Obviously. So that's the type of question you'll get asked. So then, whatever's going on, whatever their sampling strategy is, it should be easy, straightforward to determine, is it systematic or not? If it's systematic, they've got math involved. It's like this is our strategy for picking the next one each time. So if it is systematic, you're done. If it's not systematic, then here's where the problem comes into play. we have to ask ourselves, is there a partition? Whatever you think a partition might mean. A partition, officially, is when I take this population and carve it up into groups so that no member of that population can belong to two groups, but everybody belongs to one group, but not two, and not zero. So think about an excellent example is like when you were in high school, you were either a freshman or a sophomore or a junior or a senior, but there wasn't any student there that was none of those. And nobody there was two of those. Everybody was exactly one of those, right? And I could ask you, hey, are you a junior? And be like, yeah, I'm a junior. But you can't be a junior and a freshman. And there was not a student at all who you asked that question to, and they were like, I'm none of those. They're all at least one of them. So that's what it means to be a partition. Then I can only proceed. So the question to ask is there a partition? If there is, then you do what's on this page. If the answer is no, go to the next page. All right. So if there is a partition, then your choice is going to be, is it stratified or is it cluster? And they are easy to confuse. But they both involve a partition, and they are the only ones for which a partition is involved. Your choices would be stratified or cluster. And each of these definitions has the words, so we'll define stratified and then see how cluster alternates these two words. A stratified sample, we go to every part, that's not every, I go to every partition and within each one of those partitions, I make a random sampling. So if I was going to do a stratified sample of the high school population, I would collect together all the freshmen and then randomly select like 3 of them. And then I'd go over here to the juniors and randomly select 3 of them. And I'd go to the sophomores and randomly select 3 of them. And I'd go to the seniors and randomly select 3 of them. And I must visit every partition. And within each of those partitions, I make a random sample. So to get cluster, you interchange the random, I put random here and I put every there, in a sense. To have it be cluster, I have to randomly select partitions. Pick some random partitions. Maybe I pick the freshmen and the juniors. But then I would interview every single freshman and junior and not even worry about the other 2. Right? So I'll tell you one thing and then we'll go on break. I was so proud of myself because I thought of this example way before COVID even started. My example was that there's been an outbreak. There's an infectious disease spreading, and you work at the airport, and your job is to screen incoming passengers for this disease. Maybe you check their temperature or whatever. That's what you're going to do. You're going to check their temperature. Then there is a natural partition on the incoming passengers because they're in airplanes, right? Nobody that's flying into that airport is doing it, outside of an airplane. Every one of them are in an airplane. So we have a partition of the inbound passengers. They're partitioned by the airplane that they're in. If I wanted to do a stratified sample, then I would want to go to every single airplane and randomly select some passengers. Seems to make sense. That'd be a great way to get a nice sampling of everybody. Alternately, I could do a cluster sample where I randomly select airplanes and check every person on the plane. And that's an equally reasonable way to do the sample. So do you see the difference between cluster and stratified? In each case, they involve this partition. So where did we start? We said, is it systematic? Yes, you're done. If not, you come here and say, is there a partition? Well, if yes, it's got to be one of these. If there's no partition, then you're at the last two options. And they're just flat out easy to tell apart. And the only last two options are random or convenience. If it's a random sample, something random has happened that causes you to select which person is going to be in your sample. Like I have a bingo ball machine and I spin it and then the ball comes out completely at random. Or I used a random number generator on a computer. And it was able to tell me that, hey, the next one you should pick is number 67. But convenience, if there is any convenience at all to your sampling technique, it is a convenient sample. Like if I'm in the mall and I am seeing all these people pass by me and I'm doing a survey, hey, fill out my survey. Let me ask you a question. Fill out my survey. If I have selected someone to participate in that survey and they don't want to, it's instantly convenience. If you are selected to be, if I have constructed this way to pick who should be in my sample and somebody doesn't want to do it, it just got downgraded to convenience. And at worst, it would be convenience if it was something as egregious as, well, I want to know what the satisfaction is of the people in this hospital. So I will cruise by the break room and just ask the folks in there and I'm done. Obviously convenience, right? So your sample can be downgraded to convenience by way of not having everyone participate that you had selected. Or it can just be flat out convenience because you're doing what is convenient for you to select the sample. And there's nothing particularly wrong with it, it just has to be declared. And random is like the gold standard of sampling. In almost every case, a random sample of sufficient size will accurately reflect the demographics of the population, unless you need to, unless it's like really weird. Okay, let's take a break. We'll come back and we'll do these examples from the homework. You will see what kinds of questions they are asking.
Where's the nearest restroom?
Out the door, past the stairs. That's it. Walk past the stairs by where the elevator is.
Oh, really?
Yeah, I was like, oh.
Actually, I don't know if you got it, but I've had like a severe thunderstorm warning on my phone.
Oh, really?
Yeah, so I'm just, I keep looking outside, I'm like, it's just cloudy.
Yeah.
I know it rains a bit over here, so I'm just like, hopefully it doesn't.
It looks like it starts in about 10 minutes.
It starts?
Yeah, I mean, there's only a 40% chance though, so maybe.
Oh, wow.
Maybe not this area. I parked really far out there. It's like,
Mhm. Are you done after this one?
Yeah, this is the last one.
I have to stay here just now.
Oh, really? Oh, wow.
I'm taking this class in microbiome.
Oh, okay. Okay, that's a long day.
I know. Not to, because I know I'm gonna need it for next class.
majority of the questions on the homework are about the sampling techniques. 5 of them. And, well, that's the most. So, let's see. This one should be, a researcher selects every 541st social security number. Surveys the corresponding person. Systematic. A woman is selected by a marketing company to participate in a paid focus group. If she doesn't want to participate, that would be a convenient sample. But let's see. Suppose that she does participate. The company says the woman was selected because she was randomly chosen from all adults. We have to make an assumption here that there's no partition, that somehow the marketing company wasn't going to start surveying children. Right? There was only adults. And then if that was the case, then what would it be? Random. She was randomly chosen. Right? They had some sort of mechanism for choosing, which person it is. And she's on this list, and the random number generator said number 85, and that was her number, and that's how she got picked. Your question could be notably different from this. So let's try and make sure we all answer ours for this one and see if there's any problems.
We have the same question, and I chose random the first time.
What does your question say precisely?
A woman selected by a marketing company to participate in a paid focus group. The company said the woman was selected because her name was among the first 500 in the following of the listings. I'm sorry, totally not the same question.
Among the first 500.
Sorry. So it's a cluster. Well, no, it's convenient because it's among the first 500.
Not convenient.
So it is.
So, is there a partition? It's not systematic, right? Is there a partition? Well, we sort of have to read in between the lines. It would appear that they at least partitioned their list into the first 500 and everyone else, right? Now, she was among the first 500. But we don't know if she was chosen at random from the first 500 or if they interviewed everybody, if they interviewed all of those first 500. It's unclear. If they had interviewed all of the first 500 people, then it's clustered. But somehow I feel that if that's what they meant, that's what they would have said. So I would go with stratified.
Because it's a smaller group.
I would go with stratified because to be among the people that, somehow they partitioned it into the first 500 and everyone else. And that somehow she got randomly selected from those first 500. She happened to be among them. Now, I could be wrong, but that's maybe not what they meant. That is an extremely poorly worded question.
I don't know the answer is then, because it said it's not stratified. And I didn't try 10. I thought we had 10 tribes. We had 10 tribes?
5. And then it's 3 or 5, maybe it's 3. But then even if you totally get it wrong, you just click similar question and you get a new question. You try again. You can do that forever.
But I'll never know what this answer is, though. I'd like to know what the answer is.
Is it number 7?
Yes. Yes. Oh, this is the correct answer. Is convenient sampling.
I'm sorry, can you read that question?
I see why now. A woman is selected by a marketing company to participate in a paid focus group. The company says that the woman was selected because her name is among the first 500 in the phone number listings, because it's convenient.
So then our interpretation is supposed to be that they laid out this listing of 500 numbers and said, who are we going to call? I don't know. That person. Her name's among this list, so we'll just call her.
Okay.
So you see then the problem with the people that wrote these. They're not the greatest. So did you get it right, or do you have to get a new
I'm
question?
doing a sampling one now.
Okay.
So convenience is not only associated with someone who's not willing to participate?
Not only.
No.
If someone's not willing to participate, your sample becomes a convenient sample. However, it can already be a convenient sample if we are so lazy in our collection that we don't have a strategy to pick anyone. So that question might as well have said, this woman was picked. They had no strategy to do it. They simply looked at the page and said, I don't know, that one.
Can you explain to me, I'm trying to understand why is it convenient that that person doesn't want to participate? I don't see the convenience of that.
That's a great question. So,
Can I try to explain it?
go ahead, yeah.
Okay, so from my understanding, that way you can also correct me. So from my understanding from it, if it's convenient, what he's saying is that if somebody automatically opts out, that immediately makes it a convenient sample. But the whole idea behind convenience is that you would, without rhyme or reason, you would just sample the next 5 people you came across, whether or not they had anything to do with what you're actually sampling, because that's what's most convenient. So like, an example would be like, if I were to try to decide, do the students at West Coast really enjoy being here because they absolutely hate it? And I could say, I'm gonna ask every student on my way to the car. You know what I mean? Like, I don't know the people that I'm asking, and I'm just asking them because they cross my path.
So that assures that you have a convenient sample.
Okay.
Okay. And she's asking, suppose that I had a formal technique to pick my sample. Why does it become a convenient sample as soon as someone doesn't want to do it?
Yeah.
Think about me checking the temperatures on the airplane. I'm doing a cluster sample. Everybody needs to get their temperature taken. But this person here, they don't want to do it. Then it's not a cluster sample anymore. Because the cluster sample requires that I get the temperature of everybody on that plane. And if they don't want to do it and I can't make them, then it's not a cluster sample anymore. And it doesn't qualify for any of the other ones. It's convenience.
It's only convenient if someone decides they do want to and the rest don't want to. And you just stuck with the convenient amount and said yes. Maybe I don't need to know this.
No, you need to know. because there's two perspectives. Either you had decided I'm gonna have this formal way to do it, right? Mm-hmm. Maybe I want to know what everyone in the city of Richardson thinks about the price they pay for water, and I start calling, right? And I have some kind of strategy. I'm going to call all of these numbers. Maybe it was a systematic sample, right? But if people aren't answering their phones, while that's inconvenient for me, my sample now becomes a convenient sample because this is, for my convenience, all that I was able to get. Have you ever seen those surveys that they send out and there's like $1 that's included? You ever heard of that?
Yeah.
You say what now?
I would have taken this.
You would have taken that
I would
survey.
take surveys.
But if they incentivize you to participate in an attempt to assure that you will, they're trying to keep their sample from getting downgraded to convenience. Surveys are notoriously convenient samples, right? If I start surveying the people that leave the hospital about their satisfaction, I'm going to get a convenient sample. It'll never be better than that, right? But if I'm gonna start paying people to participate and would do whatever it took to assure that if I'm gonna interview every third person, then I'm gonna get every third person, even if I have to pay them, in order to avoid my sample getting downgraded to convenience. A long time ago, there was a presidential election, and there's a famous picture where the guy's holding up the newspaper and the headline says, "Dewey defeats Truman." You ever seen that picture? The newspaper was so confident that Dewey would win the presidential election based on everything that they had looked at in the days before and the night before, that they felt confident in printing the paper. However, Dewey didn't win. Truman became the president, and the problem is that the newspaper that printed that was using an analysis that was done by a very reputable magazine in the country. I forget what their name was, but they were highly reputable, and they had this long track record of accurately predicting who would be the president. But what was happening when Truman was getting elected? We had the Great Depression, right? And the manner in which that reputable firm was conducting their surveys is it was a telephone survey, and they said, how are we going to figure out who's going to get elected? Let's just call everybody that subscribes to our magazine. Exactly. Those are the people that had money. They had telephones. They could afford magazine subscriptions. And those weren't the people who came out and voted. Even though their sample that year had like 130-something thousand people in their sample, there was another statistician at the time, completely unknown, who did accurately predict that Truman would win. And his last name was Gallup. Have you heard of something like the Gallup poll? That last name Gallup, George Gallup. So pay attention if you're ever watching the news or something in the future. It'll come across the screen. The Gallup poll says this or that. And with a sample size of just 5,000, he accurately predicted who would win, because the sample was selected in such a way that it represented the demographics of the country, and he did not let it get demoted to a convenience sample. If somebody didn't respond back, like they paid them a visit, we need to know how you're going to vote. You have been selected, and it's like we need to get your info. We need to know what your feelings are, and we insist. Whereas with the telephone survey, you're interviewing people that are not demographically the same as the population, and they have the option to participate. It is a convenience sample. I did a new question on this one. It's still the woman in the paid focus group, but now she was selected because everyone in these three randomly selected towns, they interviewed everyone in 3 randomly selected towns. Conceivably, there's many towns. It is cluster. The towns partition the people. You don't really live in 2 towns, right? The towns will partition the people, and then they randomly selected some towns, interviewed everyone in the town. That's the very definition of cluster. For it to be stratified, they would have had to have gone to each town and then randomly selected some people from each town to participate. Customer satisfaction. We look at the database. We're going to randomly select 40 customers. Ask them about their level of satisfaction.
Isn't it automatic convenience you said, if it's a satisfaction?
No, not necessarily.
Oh.
If I randomly select 40 and all 40 do it, it's random.
Okay.
So I randomly select 40. And what we have to be careful of is there's another sampling technique that involves a random selection of people, and that's stratifying. But does this have any partition? All it says is they use their customer database.
So no particular.
I would agree. I do agree. However, students have pointed out to me in the past that there is a problem here with that word, current customers. But I argued back that, well, what kind of company sees, I mean, there could be an argument for, let me interview my prior customers about their level of satisfaction. Maybe I can find out why they aren't coming to my business anymore. And so the other students would say, well, what if they partitioned it into current and former customers? But just delete that word current. They want to do a satisfaction survey of their customers, so they use their customer database. Yeah. Miranda divides up her day into 3 parts, morning, afternoon, evening. She measures her heart rate at 4 randomly selected times during each part of the day.
Oh, no, I'm sorry, stratify.
Why is it not clustered? What would it take? What would it take to make this be clustered?
A natural group, and this is a divided.
If she just takes all of them?
She would have to randomly select one of these parts of the day and continuously measure her heart rate. All morning long, she's measuring her heart rate and records what her heart rate is at every single instant of the morning. That would be clustered, yeah, so this is stratified. There is a partition. You have morning, afternoon, and evening. So you have your partition, and it's not clustered because she's just randomly selecting from within all of the different partitions. Oh, I meant stratified, sorry. All right, we good so far? The man experienced a tax audit. The tax department claimed the man was audited because every 20,000th person on the list was being audited. Systematic. However, this question has some known variations that are tricky. So let me get a similar one here.
I have one.
Let's see,
Okay,
I
what-
got one too.
A woman experienced a tax audit. The tax department claimed that the woman was audited because her name was among the first 450 names on the taxpayer list.
Well, now we know what they mean by it's among this number. Reinterpret that as saying, we've got 450 names. How come she got picked? We didn't have a strategy. Her name was just picked, not at random though. Not at random. Because to pick it at random, I'd have to go to my random number doodad and obtain from it a random number. And then I could tell the person, well, my random number thing said that I need to pick you. Right? I went to ChatGPT and said, which person should I pick from this list? And it said, pick Miranda. Or whatever.
There is a partition here, the audited and unaudited, right? She's part of it. So there's no partition, and this is just systematic.
You had a question like this earlier, where it was she was picked because it was among the first 500, and it was convenience. It's analogous to the example of I'm gonna interview the students, and I'm just gonna interview whoever I see between here and the car. And it's like, those 450 people are who you're gonna see between here and the car, and that's why you got picked. You were on the way. Is it confusing? Absolutely. No doubt.
So, you said you know what among
Yeah,
the blank means, and then
Yeah.
it's always associated with
evidently.
convenience.
Yeah.
Okay.
Okay, so my question is, it says a woman experienced a tax audit. The tax department claimed that the woman was audited because she was randomly selected from all women in her age group. Would that be clustered?
Can you?
But there is a partition. She was selected because she was randomly selected from all the women in her age group. So they partitioned the women by age group, right?
Oh, stratified.
Stratified. You got randomly selected
Okay.
from the age group. If they deleted that word's age group and just said she was randomly selected, you'd be random. But because there's a partition, you have the different age groups. They are going through and they're randomly selecting people from the age groups. That's stratified. They didn't exactly tell us that we went to every age group and you got randomly selected from your age group.
Oh,
We're just left to read between the lines. Oh, that's what this one is. Except it's a guy. He was randomly selected from all men in his age group.
okay.
Stratified. Any other ones? Got 3 neighborhoods that were randomly selected. Survey everyone in the neighborhood. Cluster.
So would it be the same for mine, since it says, market researcher has randomly selected 5 businesses in a certain region,
Uh-huh.
and she is surveying all of the employees from each business?
That's clustered. Because conceivably, there's much more than 5 businesses, right? The businesses, for the most part, partition people, unless you have 2 jobs, right? And once you start interviewing everyone inside the partition, that's clustered. Any other questions on sampling technique before we go on?
Oh, I was trying to figure this one. I thought this was part of the ones.
Okay. That's the end of the vocabulary. Mostly. Still got some more to throw at you, but now it's gonna start kind of sort of being some math. Now we will discuss frequency tables. Frequency tables. A frequency table is just a little organizational tool that tells us how many times something happened. A very basic one would be like me flipping a coin. I flipped this coin 100 times, and 52 times it lands on heads, and 48 times it lands on tails. That's my frequency table. We would call this side the class, and this side the frequency. I can extend this frequency table to be a relative frequency table. If I sum up all of the things I witnessed, so the coin is only landing heads or tails, and I flipped it 100 times, that's why these 2 numbers add up to 100. Then the relative frequency would be how many times it landed heads out of the total number of times, and how many times it landed tails out of the total number of times. And you can get a percentage. So to get the relative frequency, I need to divide by the total number of observations that occurred. Now, the level of measurement here of heads and tails is just nominal, right? The interesting stuff happens when we have frequency tables whose classes are not nominal. In particular, they would have classes that let's think about being in line at the drive-through for a coffee. Then that's at the ratio level of measurement. So the least amount of time that you could wait is 0 minutes, right? You didn't wait at all. They just handed it to you right as soon as you got there. Let me do it in, I guess, minutes and seconds. So you could have waited 0 seconds to 0 minutes, all the way up to 0 minutes and 59 seconds, right? And then 1 minute to 1 minute and 59 seconds, and then 2 minutes, all the way up to 2 minutes and 59 seconds. And we have a partition of this interval of time, right? I've got time, wait time. Starts at 0, goes on forever. And I can start partitioning that interval. This is less than a minute. This is between a minute and less than 2 minutes, right? And it is a partition because everybody would belong to exactly one of these classes. So if I'm watching that person and they got their coffee after 1 minute, they belong to this class. They can't belong to this one, right? Okay. And that's what's happening with the classes. They must not overlap, right? I couldn't have this one be from 0 to 1 and then also have this one be 1, because then if you waited 1 minute, which one would you belong to? And you could make a frequency table that has these classes, and I might see 2 people that were here and 4 that were here, and 10 that were here, and then the grand total would be 16. So then the relative frequency would be 2 out of 16, and 4 out of 16, and 10 out of 16. And these have some corresponding percentage, whatever they are. I put it in my calculator and figure it out. But what would it add up to? These fractions add up to 1, so necessarily it would add up to 100%. That's about everything you need to know for, oh, no, it's not. The most important thing to know, besides this idea that the intervals of time get partitioned like this by these different classes. Partitions are no sweat by now, you've been doing them. There is a perfect correspondence between a frequency table and this chart called a histogram. We're going to take advantage of that correspondence between the histogram and the frequency table in order to make these problems oh so easy. The histogram is more or less a bar chart, but has an added feature. If we were talking about the wait times, from 0 to 0 minutes and 59 seconds, from 1 minute to 1 minute and 59 seconds, and then 2 minutes to 2 minutes and 59 seconds, and it was 2, 4, and 10. So these are my classes. They have upper and lower class limits. These are the frequencies. Then there is a histogram that describes this exact table. And the histogram, unlike a regular bar chart, the histogram's horizontal axis would be time. This is time. And my my classes start at 0, and this is a continuous interval. It's a chunk of the real number line. And I can place on there my upper class limit, or my lower class limits. So 0, 1, and 2. 3 would be there. And then the first bar would only have a height of 2. The second bar would have a height of 4. And the last bar would have a height of 10. So you can see that this picture, the bars all touch each other, right? All the points in time belong to one of these bars. Nobody's outside of one of these bars. It's a partition. And this one has a height of 2. That corresponds to me saying within this class, the frequency was 2. And within this class, the frequency is 4. And within this final class, the frequency is 10. And when we make these histograms in here in just a moment, we're going to pick an option that says for it to put the value above the bar. So it will be obvious to us that within this class, between 1 and 2, we saw four people get their coffee, and it took them, those 4 people spent more than 1 minute, but less than 2 minutes to get their coffee. Not just more than 1 minute, it could have been exactly 1 minute. But it certainly wouldn't have, if it took them exactly 2 minutes to get their coffee, they don't belong to this one, they belong to this one. Okay? Because this third classification is where 2 minutes lives. 2 minutes doesn't live up here. You see it? We can tackle these problems now. Here we have 45 commute times. They're behind this icon. And you can see there's 45 numbers, probably 5 rows and 9 columns. So there's a lot of them that end in 0 and 5. I guess when they're asking these people about their commute time, people just round, right? Okay. Some of them are not, though. They're just, who has a 4-minute commute to work? I mean, that must be nice. But a lot of people are going to be saying, 35, 45, 60, 30. That's probably the types of responses you would get. And we can take these commute times and open them in a tool called StatCrunch. We need to be friends with StatCrunch. If you aren't using StatCrunch, you are making it way harder than it needs to be. Because to complete this problem without StatCrunch would require for you to count. So first of all, I'd have to fill out all these classifications however they wanted me to do it. And then I'd have to go through and count how many were in each class manually. And I'd have to not make a mistake at any point in time. And that's really hard. They want us to construct the frequency distribution. That's a frequency table, same thing. It says use a class width of 15 minutes. Now the class width it's somewhat deceptive what you may think the class width is. Look here at this example of the drive-through time. The class width is not 59 seconds. The class width is 1 minute. This difference is 1 minute. This difference is 1 minute. The class width is 1 minute. The class width is the difference in consecutive lower class limits. So when I'm looking at this problem, and they want me to have a class width of 15 minutes, then it's easy for me to go through and quickly make this table if I first look at all of the lower class limits. Because the difference between this number and 0 needs to be 15. 15 minus 0 is 15. The next lower class limit is the next number I should fill out, because this number needs to be 30, because 30 minus 15 is 15. It amounts to us just adding 15 each time, but we don't go across, we go down. And then we have 45 and 60, and then finally 70. So I've got all of my lower class limits. Any two consecutive numbers have a difference of 15. Okay. And our measurement apparatus for measuring commute time is no more precise than minutes. I can't measure in seconds or nanoseconds or anything like that. So when I'm deciding what my upper class limits should be, I won't be able to say something here like 14.9999 minutes, right? Because that's a measure, that would imply that I had some way to measure with that degree of precision. The limit of our precision here is the minute. So this upper class limit would be 14. Just like when I was looking at the wait time example, it was presumed that I couldn't measure any more accurately than to the second. And that's why this was to 59 seconds. If it was in the Olympics and we have, if it's the Kentucky Derby and you've got the horses and this one finishes, a thousandth of a second ahead of the other one, then you'd have some different classes. You'd have different upper class limits. But in this example, my precision was the second, and here the precision is to the minute. It's commute times to work in minutes, not fractions of minutes. So my upper limits, the closest number that I can get to 15 that is not 15 is 14 in minutes, right? Without using a decimal. And likewise, that next one, the closest that it can get to 30 would be 29. Because nobody is out there reporting, hey, it takes me 29.3 minutes to get to work. Nobody's saying that. You're lucky if you get them to say 29 minutes. So, or otherwise they just say 30. So then I can now start filling out all of these upper class limits because they are just 1 minute lower than the next upper limit. And this gives you a partition. Also, you have that all of these upper limits are 15 minutes apart, which is the class width. 59 minus 44 is 15. 44 minus 29 is 15. And if I wanted to know what this number right here should be, I would go 59 plus 15 and find out that, that really is 74. And then when I want this very last number, if I had imagined a next class after this, then you'd have 75 plus 15 would be its lower limit. That's 90. So that number had got to be 89. And sure enough, 89 minus 74, that's 15. So now I've got all my classes filled out. I would need to find all these frequencies. We are not going to count it by hand. We'll be here forever. We're going to click this icon to open the data, and then there's these two blue boxes. One of them's on top of the other in the corner. Click that button, and then click Open in StatCrunch. We're going to be using StatCrunch every time we turn around. StatCrunch is just an easy-to-use piece of statistical software. It looks like Excel, operates in a much different way. It is not Excel. And Excel is very different than StatCrunch. And so we got our numbers here. They're all in this column. The column's name is VAR1. That's for variable 1. And taking advantage of that correspondence between histograms and frequency tables, we're going to draw a histogram. So we'll go to graph, histogram. When the dialog box opens, I'll tell it where my data is located. It's this variable. I'll scroll down. I'll say where they want to know. It says bins. Bins, classes, same thing. Right? It's a bucket, and everybody belongs to just one, exactly one of these buckets. And where do they start? They start at 0. They start at 0, and the class width is 15. And then the final thing to do is to click value above bar. And then it will put a number at the top of the bar that tells you how tall it is, like without a question. And so then this histogram organizes all of that data, those 45 numbers that we had. It organizes it in such a way that I can see how many belong to each class. Look, only one person had a commute time that was in this class. The majority of people's commute time is between 30 and 45 minutes. These 4 folks live real close to home, or everybody lives close to home. These 4 folks live close to work. And guess what numbers I'm going to have to put in this table? It's these. These numbers are the solution to these frequencies. So,
Can you go back to the bar, the edit? Mine was a little bit, and I thought I selected them and used them.
so did you put the correct bins?
0, 15, start at 0, width 15,
Mm-hmm.
value bar selected,
Mm-hmm.
and then I selected compute.
Okay.
Am I missing something?
Let me see what it looks like.
Maybe check the questions. We have different.
Yeah.
Well, yeah, we have different.
Well, I didn't think of that.
We have different data. Yeah.
Oh, okay.
We have different data, but for the most part, it looks right.
Okay.
And that's the frequencies that you are observing in your data set. So for me, my frequencies are 4, 13, 14, and so on. That's what I'm going to type here. There was 13 people whose commute time was between 15 and 29 minutes. I had 14 people whose commute time was between 30 and 44 minutes. If it was 45 minutes, they'd be in the next class. And we have this, we're taking advantage of this perfect correspondence between the histogram and the frequency table. The histogram is a picture of the frequency table. And all I've done is transcribe it here. Huh?
I was completely sure that, I could be wrong, that my question was exactly the same as your question.
No, you wouldn't have known that because I had 45 different data points.
This is based on the data points of the question. I see.
Oh, the question's the same problem,
Yeah, okay,
but
so-
our data is different,
Okay.
no doubt.
But the time of commute is gonna be exactly the same. I get you.
Okay. Now they sprung another word on us. I say it's a little early to be asking about normal distribution, but the normal distribution is the main topic of study of the whole course. And normal distribution. Now this is a a frequency table is a frequency distribution, and this is a picture of that frequency distribution. It shows us how that data was distributed into the different classes. A normal distribution satisfies, well, let me back up. If the distribution is approximately normal, which is an important thing to say, if it is approximately normal, it satisfies two things. Number one, it increases to a maximum and then decreases back down to a minimum. It increases up to some maximum before it goes back down to some minimum, as I look from left to right on the table. The second property is that it's roughly symmetric. So if it's roughly symmetric and it increases to a maximum and then back down to a minimum, then it is approximately normal. To be exactly normal, nothing in the real world will be exactly normal. It would be fictitious data. So we will, if they say, does it appear to have a normal distribution, that's the same thing as saying, is this approximately normal? Okay, well, look at our chart, or look at mine at least. It goes up to a maximum, it goes down to a minimum. Is it roughly symmetric? It's roughly symmetric. It only needs to be roughly symmetric. Let me tell you what wouldn't be roughly symmetric. If this was the tallest bar and they kept decreasing in height, that would not be normal, because it didn't go up to a maximum and then down to a minimum. And it certainly wouldn't be symmetric. If I had 10 more bars over here, they just kept getting smaller and smaller, it would not be symmetric, not by a long shot, even though it increased to a maximum and back down to a minimum. So yes, this appears to have a normal distribution.
So you said it wouldn't have a normal if the 14 and 13 were switched?
If the 14 and 13 were switched, we would be right on the edge of how rough something could be and still be considered roughly symmetric, right? In all likelihood, the answer to the question on yours is yes, that it's roughly it appears to be normal. You have the tallest bar, for the most part, in the middle, and it goes up, it goes back down, is symmetric. Pretty much. Especially if I took away that 1 over there at the end, then it would be really close to symmetric. It doesn't like what I said. So I picked yes, because the frequencies, I just assumed that it would be yes. The frequencies start low, proceed.
I guess it would be no.
Well, the only other option is that it's no, but the reason would be why. So,
Approximately symmetric.
The problem is that approximation is not well defined here. One person's approximately symmetric is another person's wildly asymmetric. And in most other cases, in these assignments, something like this would be considered approximately normal. It's a largely inappropriate question to be asking in the first assignment because we have no idea what it means to be normal. It does increase to a maximum and decrease to a minimum. That's satisfied. So the violation must be symmetry. And this 4 and this 5 are pretty close. We can ignore that kind of. Then the only asymmetry is this 13 and this 8. And it's kind of pushing it that this is asymmetric, but I don't have a choice. That's what it's got to be. So no, because while the distributions start low, proceed to 1 or 2 high frequencies, then decrease to a low frequency, the distribution is not symmetric. examine the data and identify anything appearing to be unique. Well, I'll help you cut to the chase here. We already observed that a bunch of those data points ended in a 0 or a 5. Oh, yeah, it's 20 minutes my commute time. Oh, it's 35 minutes. People are rounding, right? Besides that, who out there would ever say, oh, my commute time is 8 minutes, you know, or even knows that, right? You would just say 10. So I'll go with C. Examine the data and identify anything appearing to be unique. Select all data apply. Most of the data values are rounded to the nearest 5 or 10 minutes and may be estimates of actual commute times. The unusually large value of 80 minutes appears to be an error in the recording data. I don't have any reason to believe that. It could very well be the case that that one person, that their commute time is 80 minutes. Maybe they live out of town, you know? So, all right, that's the end of that question. Pretty much all of the questions from here on out are having to do with frequency tables, at least in this assignment. So now we can do this one pretty easily. It's about screw lengths. So we've got like a bucket of screws, like, you know, like deck screws. You're going to build something. And look at the precision with which we can measure the length of that screw. 3 digits after the decimal. The class width is 0.010. Okay. So I can go through and fill out all of these lower class limits because the class width is 0.010. This next one is just going to be that number plus 0.010. So it's 1.730. And then the next one is 1.740. 1.750. 1.760. Just adding 0.010 each time because that's the class width.
Can you say that again? How do you add the width and then kind of?
So which digit is changing? Whoops. Which digit is changing? It's the second digit because 1.720 plus 0.010. The only thing that changes is that the second digit jumps up by 1. 1.730. 1.740. It amounts to me just taking that second digit and letting it increment by 1 all the way down. Check to see that 1.750 minus 1.740 is the class width, 0.010. I mean, it is. You can certainly do it in your calculator, but it should be. Hopefully, by the end of this course, at least, we could be able to see that it is without having to look at the calculator. Because what if it just started at 1? 1 plus 0.010 is 1.010, right? And the only difference between 1 and the next one is that the second digit was incrementing by 1. It's just like if I was going to add 0.001, then the next one would be, it would just be that third digit that increments by 1. Got it?
I guess my question is, why did we choose that digit? Because
They told us.
They told us and we used
Yes,
the
they
class
said,
width.
use a class width
Okay.
of this amount. Yeah, they got to tell you what the class width is.
Okay, I get it now. I must have missed something.
Now, the precision with which I'm measuring these screws is to 3 digits. So I should put a number here that is as close as I can get to this one using 3 digits that pass the decimal. Yeah, 0.729. 1.729. 1.739. 1.749. It's essentially the very same number as the lower class limit, but the lower class limit ends in a 0, and that one ends in a 9. It's as wide as it can be. 1.76 now. So now I've got all of my lower and upper class limits. Time to get the frequencies. Okay, so I'll make a frequency table, or I'll make a histogram, open the data, click the button, open in StatCrunch. 30 numbers are now opened in this column. And you can see what a pain it would be if I had to do this manually. Here we can just say that we want to graph a histogram. You tell it which column the data lives in, what your class limits are. 1 point, I don't remember what mine started at, 730? And the class width was 0.010. I'll go with 1.730, and if I need to change it, I can come back. And then I'm going to click value above bar and compute. So mine actually should have started at 1.720. Okay, so I need to make a change. How can I do that? Go to Options, Edit, and you can go right back in without having to start all over. So it really needs to start at 1.720 and then go up by 0.010. And I can see here in the picture, look, there's 1.720, and the next one after that's 1.730. I've got 5 different classes, 5 different bars, and that corresponds to, hopefully I got 5 rows in this table, 1, 2, 3, 4, 5. And the frequencies are just the height of the bars. There was only one screw in all that 30 of them that fit in that classification, and 6 of them in that class, and 10, and 11, and 2. That's the end of that question, just to fill out that table. And they don't ask us a bunch of extra stuff. Are we succeeding? Question 14. So we have question 14 and 15 left to go. In question 14, they're talking about relative frequencies. Now there's a key observation that makes this question very easy. They're talking about filtered cigarettes versus non-filtered cigarettes. So if a cigarette has a filter, then we can assume that that as the air is drawn through the cigarette filter, some of the tar is being captured by the filter. Filtered cigarettes have a lower tar than non-filtered cigarettes. However, when I look at these frequency distributions, they did not make it so that both of them had the same classes. Over here is filtered cigarettes. They have lower tar. That's why they have the class from 5 to 8. Evidently, there aren't any non-filtered cigarettes that have between 5 and 8 milligrams of tar. I'm guessing it's milligrams. Every time, for any non-filtered cigarette that they checked, they all came out above 5 to 8 and 9 to 12. In fact, the lowest tar in a non-filtered cigarette was in this class of 13 to 16. Likewise, the filtered cigarettes don't have the, So this one has the lower classes, but it doesn't have the upper ones. It would be strange for a filtered cigarette to have a very high amount of tar just like a non-filtered one. So what we should do to make this easy all of a sudden is to construct the frequency tables that has all the classes for both of them. So in other words, I want this one to also have the class from 9 to 12. And I want this one to also have the class from 5 to 8, but their frequencies would just be 0. Right? So by me modifying the table this way, I haven't made any more observations. All I've done was just stick in that class for which there were no observations at that level of tar. But now both of the tables are going to have the classes of 5 to 8 and 9 to 12. It's just that there were 0 observations there. And then over here on this one, I need to put in these last 3 classes, but with 0 observations. Then each of these tables would have the exact same classes. And I'm just putting a 0 in for the observations because I didn't see anything happen there. Now, both of these tables now have 7 classes, right? So now I am able to go through and fill out the relative frequency table, because here on the relative frequency table, they have all of the classes. That's the tricky part. Let me write down over here on the side 2 columns of numbers. The first column will be the non-filtered cigarettes, 0, 0, 2, 0, 14, 7, 2. My second column will be the frequencies of the filtered cigarettes, 1, 2, 6, 16, 0, 0, 0. Because I'm going to have to erase this and close that little window. All right, so now I've transcribed my frequency tables. Right? They're over there. And our goal is to make the relative frequency table. Well, that just means we're dividing by the total. Okay, so here you had 25 cigarettes in this list, and 25 cigarettes in this list. So evidently they took 25 filtered cigarettes and 25 non-filtered cigarettes and checked how much tar each of them had. The totals here are 25 in each case. All I want to do is fill out what the relative frequency would be. So I'm going to take the corresponding number from that class and divide it by 25. So this one is for non-filtered cigarettes. That first number there is 0 over 25. Well, that's 0%. For the filtered cigarettes, the number is 1. So it's 1 over 25. That's 4%. 1 over 25 is 4%. 0 over 25 is still 0%. 2 over 25, that's 8%. 2 over 25 here, that's 8%. And then 6 over 25 is 24%. How am I doing that so quick? Well, I mean, 6 over 25 times 1 is 24 over 100, 24%. I've just multiplied by 1, but it has left me with a 100 in the denominator. So now I can see that 6 over 25 is 24%. So that's where I get the 24% from. Then here for my fourth class of the non-filtered cigarettes, we're back to 0. And for the fourth class of the filtered cigarettes, the number is 16. So it's 16 out of 25, but 16 times 4 over 25 times 4 is just going to be 40 plus 24, that's 64%. To have 16 out of 25 of them be in that class, that's 64% of them. 14 out of 25 is 56%. And then 7 out of 25 is 28%. And finally, 2 out of 25 is 8%. We can certainly go through and check that these percentages add up to 100%. They better add up to 100% or we've done something wrong. And that's the problem. You extend your frequency tables to have all of the classes and then just compute the relative frequencies. If what I've done here is confusing, you can certainly just use your calculator. 16 divided by 25, you're going to get 0.24. Or 16 divided by 25, you're going to get 0.64. Time's up for the day. So, the only question we didn't get to was the last one. I claim, I'm not done, evidently. Continue. They're going to ask me, are filters effective? Yes. They're not effective in making it safe. They're just effective in reducing TAR.